Why are cells so small? No matter if you're an ant or an elephant, you have small cells. Now this cube here represents a cell, and we can see that currently it is small, but cells can grow. Once they reach a certain size though, they divide. Why do they try to maintain that small size? They are dividing to keep that small size. Now, the reason why cells are so small is because it relates to how efficiently they can move nutrients into the cell, how fast they can get toxins out of the cell, and how they can exchange gases. Now, the surface area to volume ratio helps us determine how efficient a cell is. So the surface area to volume ratio can determine how efficiently a cell moves materials across the membrane to keep it alive. So let's start with surface area. Surface area refers to the outside area of an object. So the area on the outside of an object. So when we're referring to a cell, the outside of the cell is the cell membrane. So surface area of the cell shows the size of the membrane. So we have, for our example cell, a cube. And in a cube, all the sides of the cube are the same. And a cube has 6 faces. So to figure out the surface area of the cube, we take 6, which is the number of faces, times the side squared. Because length versus width, it's the same in a cube. So we can just call length and width side, because they're the same, and square it. Volume refers to the amount of space inside of an object. So referring to the cell, what is the space inside of the cell? That's where we find our cytoplasm. That's where we find all of our organelles. So volume shows the amount of stuff, that cytoplasm and organelles, inside of the cell. And because in a cube, length, width, height, they're all the same, how we find out the volume of the cube is we take the side and we cube it. One last step to calculating out surface area to volume ratio is to take our surface area that we just calculated and we divide it by the volume. So let's do an example practice problem. Here's our cubic cell with a side of 2 centimeters. First thing we're going to do is we're going to figure out the surface area using that equation of 6s squared. So we know that our side is 2. We are going to be squaring our 2. We get 4. And 6 times 4 is 24. So our surface area is 24 centimeters squared. Now for the volume, we use the equation s cubed. So we are going to take that side of 2 and we are going to cube it. 2 times 2 times 2. 2 times 2 times 2 is 8. There's one last thing we need to do to figure out our surface area to volume ratio. And what we need to do is divide. We divide our surface area by our volume. And we get that the surface area to volume ratio is 3, or 3 to 1. So how does this apply to how efficient our cells are at moving materials across the membrane? Does it tell us how we're going to get food in easier and waste out easier? It actually does. So the higher your surface area to volume ratio ends up being, that shows that your cells are more efficient at moving things across the membrane. And a lower number for your final calculation of surface area to volume ratio shows that your cells are less efficient. Now let's take a closer look at why this is. So I have this small circle representing a smaller cell. I'm going to draw an arrow going in for showing that food is coming into the cell across the membrane. The membrane is where we take those food nutrients in. Additionally, I'm going to draw some arrows coming out, showing that waste is leaving the cell. So we can see in this small cell, because we have this certain amount of membrane, it's very easy to get enough nutrients in and enough waste out of the cell. Now, my second circle represents a cell that is bigger. Now, in my bigger cell, I'm going to draw my nutrients going in, but I actually have more space. My surface area got bigger when my cell grew, so I'm going to draw more of these nutrients going in. I'm also going to draw more of these nutrients going out. So when my cell grew, the surface area got bigger. However, look at the middle of my cell. The volume also got bigger, but the volume of the cell got bigger faster than the surface area. In this picture, it looks like that middle of the cell is not taking in food and it's not getting rid of waste. That means that my cell is not moving molecules across the membrane as efficiently as it needs to. So that shows when a cell grows, volume grows faster than surface area, making larger cells less efficient. Now I have a fun way to remember this. The way that I always remember this is I just think, ooh, that's smelly. What does smelly stand for? It stands for small cells are more efficient, whereas larger cells are less efficient. So when you are figuring this out and you can't remember, are large cells more efficient or smaller cells more efficient, you want to think to yourself, smelly. The smaller your cell, the more efficient. The larger your cell, the less efficient.